to. All right. These are the objectives. When you're all ready, let me know so we can go on to the next slide. Are we good? Yes? All right. So negation just means not, remember? So if you have P and not P, if P is true, not P is false. If P is false, not P is true. They have opposite truth values because they're just complete opposites, well, kind of. Right? P, not P. They have opposite truth values. One's true, one's false. If one's false, the other's true. So then we have conjunction. Remember, that's the word and. Conjunction means together. When it comes to truths, when we say the word conjunction, what we mean is that they both need to be true at the same time. Right? It's the word and. So with the word and, the truth table for P and Q, right? This is the third column that we don't have filled out yet. It will be true when both statements are true. So that first row of true and true, that's going to be true. That's going to be true because P and Q are both true. It's an and statement. P and true. P and Q. Right? So that statement is only true when both are true. So if P is true and Q is false, that's going to be false. If you have false and true, that's going to be false. False and false is false. Right? It's a conjunction. It's an and statement. So the whole statement is true only when they're both true. Okay? Any questions about that? No? Okay. Now we have an or statement. Remember, or just means one or the other needs to be true, right? So in this case, for P, if P is true and Q is true, well, that's going to be true. Right? They're both true, so one's true. For the second one, if one is true and the other is false, remember, or just means at least one of them needs to be true. So that's going to be true. False and true, well, one of them is still true, so the whole statement is true. The last one, false and false, that's going to be a false statement because they're both false. Neither is true. Is that making sense? Are we making these tables? Because this is kind of like a basic table, and we're going to get to a point where it gets a little more involved, a little more complicated. So make sure you understand this. If you don't, let me know before we keep going.
So if it's
That's or.
it means it means it's
If it's or, it means only one needs to be true for the whole statement to be true. Right? Or just means one or the other, or both. So at least if one or the other is true, the whole thing is true. While with the previous one, this is and. They both need to be true. So P and Q need to be true for the whole thing to be true. All right. So using the definitions of negation, conjunction, disjunction. So here, let P be 10 is greater than 4 and Q is 3 less than 5. Those are both true statements. So P and Q, since both are true, the conjunction is going to be true, right? You can kind of think of it as, well, if one is true, so if this is true and true, right? If you kind of think of it, P is true and Q is true. So since they're both true, the whole conjunction is going to be true. For the second statement, B, not B and Q, well, not P, sorry, not P. So if P is true, that means not P is false. So what we really have is false and true. Right? False and true. So since it's an and statement and not both of them are true, that's why this statement is false. Conjunction or the and statement is very picky. They both need to be true statements for the whole thing to be true. That's why for part B, the not P and Q, that's a false statement because one of those is false. Are we fine with that? Okay. All right. Let P and Q represent the following statements. P 10 should be greater than 4. Q 3 is less than 5. Those are both still true. So Now I have or statements. So for C, I have P or not Q. So P, well, that's obviously true, right? So I have a true statement or not Q. Since Q is true, the not of it is going to be false. So I have P or, sorry, T or F, true or false. Are y'all find how I got that? Makes sense? All right, since it's an or statement, I only need one of them to be true. So because of that, this is a true statement. When it comes to or, only one of them needs to be true for the whole statement to be true. Right? Or is just kind of one, the other, or both. Doesn't matter. So now I have not P and or, sorry, not P or not Q. Well, what I have here is false or false. Since they're both false, the whole statement is false because neither is true. Everyone with me? All right. Anyone still copying or ready to keep going? All right, let's keep going. So now we're going to create truth tables that are a little more complicated. Like let's say I want to do a truth table for P and not P and Q. Right here, I want to see the truth table for this. What you're going to do something more complicated like that is you kind of want to figure out the individual parts. You kind of want to do each individual part and then bring it all together at the very end. Okay? So we start with P and Q. So P is true, Q is true. For an and statement, that means it's going to be true. Right? For an and statement, they both need to be true. So if P and Q are both true, the and statement's true. For the second row, true and false, well, not both of them are true. It's going to be false. And that's the reason for the next two rows as well. It's an and statement. It's very picky. They both need to be true for the whole thing to be true. Make sense? All right. So that is the first part of the table. But now I want to figure out, well, how does that help me get the truth value of not P and Q, right? So what I want to do here is I want to know, we don't have to worry about this right now, but what I want to know is, well, if P and Q, right, we did the statement right here, we can kind of fill this back out. That's true, false, false, and false. What I want to know now is, well, if P and Q is true, how about this not version? Remember, the not version, what it does is that it flips its truth value. So if P and Q is true, the not version of that is going to be false. Make sense, guys? So it's the not version of it, so you reverse its truth value. That's really what the conjunction means. This not, the squiggly line, that really just means not. It means you're gonna reverse its truth value.
So
Parentheses is parentheses.
just P and Q.
I'm sorry? P and Q
It's P and Q, and then you do nothing. So
is the opposite of it, yeah. So P and Q, the second column, is P and Q, right? That's what we did in the previous slide. The not version of this is when you negate its truth value, so you give it the opposite truth value. So if P and Q is true, not P and Q is false. If P and Q is false, not P and Q is true. So all those are going to be true because the not version of it is going to negate it. Yes.
what we say to assume that if you see like the not sign, then you would just take the other table from before and just flip this.
I wouldn't say it like that because these can get more complicated. I think we'll see some examples later. What I would really think is if you have a not version of it, look at its column. Right? So P and Q, well, the not version of it, these are kind of the same thing. There's kind of opposites. P and Q, not P and Q. So that's why they're complete opposites. True, false, false, true, false, true, false, true. Because they're opposite that way. Makes sense. All right. Any other questions, guys? Are we okay? All right. Now we have one that's a little more complicated. I want to construct a truth value for not P or Q and not Q. All right. So let's actually simplify these a little bit more. I actually don't like how they do this. Okay, it's not a big deal. All right. So we're actually gonna get rid of all this. All right. So I have P and Q. All we're doing here is we're listing out all its possibilities. So with P and Q, we're listing out all the different possibilities between the two. So you have true and true, true and false, false and true, false and false. These are all the possible pairings you can have in P and Q, because those are the two letters we actually care about. And then we're going to negate its P. So this first or the second column, sorry, since this P is true, not P is false. That's true, that's false. That's false, that's true. That P is false, that P is true. Right? That second column of not P will have the opposite truth value of the P. And now we're going to look at not P or Q. So remember, not P or Q, all that means, all you need to look at is this row right here and this row right here. I only care for these two when it comes to not P or Q. And remember, or just means one of them needs to be true. So I'm going to look at these two and just to decide, well, what should be here. So not P or Q. Well, between these two, the true and the false, one's true. So that's going to be true. The second one, they're both false. P and not P. Sorry, Q and not P. Or Q or not P. They're both false. That's going to be false. True and true. That's true. False and true. That's true. Remember, only one of them needs to be true for an or statement. That's all it needs to be. Any questions about that? All right. And then now we have not Q. So now that we have not Q, we're going to take the Q's and negate the truth values. So in the first row, I have a T. So this is going to be false. I have a false. This is going to be a true. A true means false, and a false means true. I'm doing it a little quickly, but all I'm doing is I'm taking the Q row and putting its opposite truth value. It was false, true, true, false, false, true, true, false. All right. And then finally, I have not P or Q and not Q. This one's a little tricky. What we're going to do here is I have this not P or Q right here. That's this column right here. Okay? And I have not Q. Well, not Q is going to be this column right here. So you have to be careful with what you're splitting up. I'm talking about these two statements, not P or Q and not Q. So if I want to figure out the truth value of this last column, what we did before is we kind of took out every individual part because I want to figure out ultimately, well, what is the truth value of not P or Q and the truth value of not Q and combine it at the end. So because it's an and statement, I need both of these statements to be true at the same time for this last one to be true. Everyone with me? I know these truth tables can be a little confusing to kind of set up at first. Which one? So the last column is what we ultimately want, right? Because what I want is a truth value for this statement. So this whole table, what we were doing is we were kind of breaking it up because we have P's and Q's, right? So I said, well, let's go ahead and assign P's and Q's to the truth values. Then I negated the P, so I'm going to figure out, well, what about not P or Q? I want to figure the truth values for that, right? That's why we put the not P here, and I figured out the first part, the not P or Q. I figured that out with this column here. And then I figured out, well, I need the other side of that, the not Q's. So I made a column for that. And then ultimately, I'm going to put it all together in that last column. Are you okay with this? Any questions about anything? Because I know this can be a little confusing. Kind of. If you have any questions, let me know. I'll try to explain it differently if I need to.
So that's P and Q.
P or Q, not P or Q.
That's not P and Q.
Which one? This one?
Yes.
That's not P or Q. The V is or. So V is or. That's or. The upside down V is and. All right.
Okay. That's not.
Yes, not Q. The squiggly line means not. It's the opposite truth value.
And we're just not.
Put it all together now. Because now that we have the part, like the big parts that I want, I can put it all together. So not P and Q, or Q and not Q. I need to know when they're both true. Well, in this first column, that's true and false. That's going to be false. The second row, I have false and true. That's still false. True and false is still false. Finally, the last one is true because they're both true. Does that make sense what we're doing, guys? Any questions before we keep going? Because it does keep getting more complicated than this. And also, I'm not sure if you'll see it, but maybe you will. But it is possible to have nothing be true because maybe I gave you a complete nonsense statement and nothing works, so it's just false all the way around. That is possible. Yes. I don't know if you'll see a case like that.
So nothing means false.
No, I mean like no. You'll get like maybe sometimes you get like a column that goes false, 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 and false. Like sometimes that does happen. I'm not saying you'll see it. I'm not sure if you'll see it in the homework or I've made the test. Yeah, I don't think I'll put on the test if it's not in the notes. But I'm just saying more. It could happen, and everything's false. So the statement doesn't make sense. All right. So now constructing a truth table with 8 cases. This happens when you have 3. All right, so you could have 3 different statements, a P, a Q, and an R. If that happens, you're going to have 8 different combinations. Every time you add another variable, your total cases increase or they double. 2 cases is 4, 3 cases is 8. If you have 4 variables, you'll have 16, 5 would be 32, etc. You're not going to get that, you don't get anything that crazy. I think 3 is going to be like the maximum. All right. So from here, we're going to construct a truth table for the following statement. I study hard and ace the final, or I'll fail the course. Suppose you study hard, you not ace the test, whatever that is, not a big deal. The point is, P is I study hard, Q is I ace the final, R is I fail the course. These are the 3 statements we have, because these are the 3 things in that statement that can have a truth value to it, right? It's true or it's false. You studied hard or you didn't. You aced the final or you didn't. You failed the course or you didn't. You either did or you either did or you didn't is a truth or false statement. So for here, I want to know, well, what is the truth value of, what was it? Of that statement. So P, I want to know the truth value of P and Q or R. I studied hard and I aced the final, or I failed the course. All right. I want to know what is the truth value of this compound statement right here. So this table, how they set it up, is they started with the variables, P, Q, and R. We always want to start with the statements, the variables by themselves, because that's kind of the basis of the whole thing. What it really is, you're kind of starting with the small parts, the P, the Q, and the R, and you're building up to the bigger statements. So that's why we start with P, Q, and R, and these are all the 8 combinations of truth and false statements between the 3. Does that make sense what we're saying? So the first statement I have in parentheses, that's what I want to figure out what's the truth value of that. Once you have your 3 statements, the P, the Q, and the R, what you want to do next, this next column, how you figure out what that's going to be, is that's going to be, well, what's the first kind of statement I have to prove here? In this case, it's the P and the Q, right? It's this one right here. That's why it's the next column over. I want to know, well, what's the truth value of P and Q? Right? It's an and statement, so P and Q is only true when they're both true. I don't care for R. So that's why the first row is a true statement. It's a true statement because P and Q are both true. The second row is also true because P and Q are both true. I don't care for R. There's no R in this column. In this third column, there's no R, so I don't care what R is. I don't care if it's true, if it's false, if it's nonsense, it doesn't matter. All I care for is P and Q. That's why this third row is also true. Well, everything else is false because P and Q never are both true ever again. Are you fine with how we got that third column? Any questions about that?
Yeah. So, we both.
Yes, and statements means both P and Q both need to be true at the same time for its truth value to be true. That's why these two rows are the only ones that are true, because that's the only time P and Q are both true.
Oh, there's R.
There's R.
What about R? That if it's false, then it doesn't matter.
Well, do you see an R in this column? Do I care for R here?
No.
No, so that's why in this column I don't care for R. But R is there because it's in the big statement. Right? Now I'm going to put it back together with R. So this last column here, I want to know, well, I have P and Q or R. I want to know, well, when is P and Q true and when is R also true? Does that make sense, guys? Any questions before I fill this out?
So, P and P.
Or R. So either one needs to be true. So P and Q, the first two rows are both true, right? Because all I care for is one or the other to be true. I care, well, P and Q, is that true? Or is R true? One or the other. So these first two, I know they're gonna be true right away because P and Q are both true here. Now for the rest of them, I know P and Q is false for all of these. So I'm gonna look at R because I see one or the other to be true. So now I'm gonna look at R. Well, really looking at both of these, but look at R. Well, R is true in this third column. That's gonna be true. In this case, P and Q or R, those two columns before it are both false. This is false. This column, the R is true, the P and Q is false, so it's true. I just need one of them to be true. This statement, they're both false, that's false again. For this one, the R is true, the P and Q is false, so this is true. And finally, the last one is also false because they're both false. Make sense, guys? Are we okay? Okay. Sure.
You know, those three.
Uh, I'm not 100% sure yet. I'm gonna have to see. Yeah, I'm not. I'll let you know next class. Just remind me of the question. I'll let you know. Any other questions, guys? Are you okay? Sorry. Okay. All right. Yes.
It was false.
Because all I care for right now, this last statement, I'm looking at this row, this statement right here that comes from this column. Okay. And then I care for this R, which comes from this column. So I'm looking at these two columns right here. I'm trying to see, well, which one, when are they both, when is at least one of those two true? There we go. I'm trying to see, well, when is at least one of these two true? And in this case, in these two rows, at least one was true. In this row, also one was true. In this case, they were both false, so that's false. At least one of these two was true, so that's true. Right? Make sense? Okay. So, in this case, determining truth values for specific cases. We can determine the truth value of a compound statement for a specific case in which the truth value of the simple statements are known. Without constructing the entire truth table, substitute the truth values of the simple statements into the symbolic form of the compound statement, and use the appropriate definition to determine the truth value of the compound statements. It's just saying, figure out the truth value of the simple stuff, put it together and see, well, is it all going to be true together? All right. So the bar graph in the next slide shows living arrangements of U.S. young adults aged 25 to 34 from 2000 through 2017. We're going to use the information in the bar graph to determine the truth value of the following statements. It is not true that the percentage of young adults owning their homes is decreasing and the percentage living with parents is increasing. Or We have the word or. It is not true that in 2017, 11.9% of young adults lived with parents. A lot going on there. This is the bar graph that we have. All right, we'll come back to it in a bit. But what we want to do is we want to kind of pick out what are the statements that are saying. What are the true or false statements that are happening here? All right. Everyone with me? Any questions up to here before I keep going? So these are the three statements that have true or false statements, right? Or true or false truth values. The percentage of young adults owning their home is decreasing. That's true. The percentage of young adults living with parents is increasing. That's also true. In 2017, 11.9% of young adults lived with parents. That's false. So when you're given a statement, if you don't feel like doing the whole table, or I'm sure none of y'all want to do that, what you could do is list out each statement. Right, each statement has to have a truth or a false truth or false value to it. So one statement the problem said is the percentage of young adults owning their home is decreasing. That's true. Percentage of young adults living with parents is increasing. That's also true. In 2017, 11.9% of young adults lived with parents. That's the other statement the problem gave me. Well, that's false. It was 22% that lived with parents. And then from there, what you can do is rewrite the actual statement it's giving. It's saying what the statement was is it's not P and Q or not R. That's what the statement said. It's not P or Q or not R. And from there, because we know that P is true and Q is true and R is false, you can substitute those in. So the P and Q are both true. So we can substitute this in for true. So we have true and true or not false. You have fun with that? So true and true, that's just true, right? True and true, you don't need to keep the whole thing in there. You can rewrite that as just true. So this became just true. So now we have not true or not false. Negate those false or true, which gives you the final answer of true. It's kind of a lot, but essentially what you're doing is you're finding the statements. You're trying to see, well, was that statement true or false? That's really what it boils down to. And then you use the rules of ands and ors and negations to kind of simplify it all the way down to eventually get true. Does that make sense what I'm saying? Or is that kind of weird? Any questions? Is it kind of weird? I don't like these examples they give, but I'm trying to work with it. Let's do a new slide. How do you do a new slide? So I'm going to give it kind of a simpler example. Let's say P is that 10 is greater than 7. Q is 15 is less than 3. And then R, the final statement, can be, I don't know, what do y'all want? 7 is less than 17. I don't know. Doesn't actually matter. Right? Say we have these three statements. P, Q, and R, okay? And I want to know, let's say I give you something crazy. I just say, well, how about this? How about not P or Q and, oh, not an A, but, there we go. Or not R and Q. I don't know, something crazy like that, right? What this thing was saying is just saying, look, you know P, Q, and R are actual statements. Figure out, are they true? Are they false? What are they? So in this case, P, 10 is greater than 7. Is that true or false? That's true, right? Q, 15 is less than 3. Well, that's false, right? And 7 is less than 17. That's also true. You're trying to figure out, well, P, Q, and R, the three statements, Are they true, false, or what? And then you can replace in this statement these statements. So what we have is not, well, P is a true statement, that's true, or Q is a false statement, that's false, and not R, well, that's going to be not true, right? Because R is true. I'm just replacing the R's for right now. And Q is false. Everyone with me? Y'all get what I'm doing now? And then I can keep simplifying this down, right? So now true or false, well, because remember, an or statement just says at least one of them needs to be true, right? So true or false, that's going to be a true statement. So this right here gets replaced with true, and then not, the negation has to stick with it. So now it's not true. The true came from true or false. And then we have and. This not true or false, well, that's just saying false and false. Everyone with me up to here? Y'all get what I'm doing? And then false and false, well, that's just going to be false, right? So now we have not true, which is false. And false is false. I'm not sure why I keep doing A's. Okay. There we go. So false and false is false. So I have a false and a false, which means this whole statement I did from the very beginning is false. And that's your final answer. Does that make a little more sense how the thing goes? Any questions about that? It's really just list out your statements and figure out, well, are those statements true, false, or what? And then with the actual compound statement it gives you, what it wants you to do is replace it with those true and false statements and keep simplifying it all the way down so you're left with just one statement left over. In this case, it ended up being false. Any questions about this before we go on to the next unit, 3.4? We're good? You okay?
All of this was.
Oh, I just made this one up. It's because the statements they keep giving us like these really complicated like paragraphs. So I think it's kind of confusing trying to go with this. Just trying to read it and understand what's it really saying. So I just kind of made some random statements. I just said, well, let's say the statement P is 10 is greater than 7. Then let Q be 15 is less than 3. Then let R be 7 is less than 17. I just made 3 statements up. And then what you do from there is you assign them truth values. So P is true, right? It's a true statement. 10 is greater than 7. Q is a false statement. 15 is not less than 3. And the third one, R, 7 is less than 17. It's a true statement. And then this red one right here, I just made something up. I just kind of wrote whatever I felt like writing. And then what we do from here is each statement, it's true or false, right? We don't know if it's true. What we do know is if it's true or false, so we can replace it. P is true, so I replace it with true. Q is false, I replace it with false. R is true, I replace it with true. Q is false, I replace it with false. That's what I got from here to here. I replaced the statements with their actual truth values, so that's all I care for anyway. And then I kept simplifying it down. True or false. Remember, for or, just one of them needs to be true, right? So one of them is true. I can replace this whole statement with just true. The negation just follows it. And now the and statement, I haven't done that yet. Not true and false. Well, not true is just false. So now this becomes false and false. Well, false and false, they're both not true. If and means they both need to be true. Well, neither are true, so that's a false statement. Not true is false. So false and false, well, it's an and statement, right? So they both need to be true. It's false. Kind of make sense? Anyone else, guys? Are you okay? Ready to keep going? All right. 3.4. Well, yeah, we have to do it this week. It's pretty short, though. All right. Truth tables for the conditional and the biconditional. Basically, what we're doing here is we're now going to use the, remember the arrows and the arrows going both ways? We're doing that now. So these are the objectives. When I'm making the test, I'm just going to go through the objectives and make sure you can do each thing. I'll try to list out all the objectives in one place. So you can kind of go over it if you need to. But that's kind of when I'm making the test. That's kind of how I do it. I just kind of look at each objective and make sure I've asked a question for each objective. All right. So you want to take a picture of it or whatever you want to do, go for it. Everyone have this written down? Ready to keep going? All right. So, conditionals can be a little weird. A conditional is false only when the antecedent is true and the consequent is false. Basically, what that means is that this is only false when you have something that says true implies false. If you think of it logically, it kind of makes sense. How can a true statement imply something that's false, right? It doesn't really make much sense logically. That's why for conditionals, a true statement can never imply a false statement. So if you have P and Qs, we can still make a table like we always did. The only time this is false is if you have a true implying a false. All right? That's the only time it happens. A false statement can imply a false statement, and a false statement could imply a truth statement. That could happen. But a true statement can never imply a false statement. It's kind of weird, but that's how it goes. Ready to keep going? No? Okay. And a lot of this stuff is really just understanding that ands mean they both need to be true, or it's just one needs to be true. Conditionals, it just cannot be true implies false. It cannot be that. And the biconditional is going to be also kind of weird, but we'll get there when we get there. Ready to keep going? All right. So, constructing the truth table. I wanted to fill this out myself. It's not a big deal. So, P and Q, the same thing. We're dealing with P's and Q's. So, we're going to start with just listing out all the combinations of P's and Q's. True and true, true and false, false and true, false and false. You always want to start with the actual statements themselves and write all the pairings that you can have with them, or if they're threes, all the groups of threes you can make with them. All right. So now we have the column not Q. We are doing that because we care about not Q implies not P. You're starting with the actual statements themselves, and then you look at the problem that we're solving. In this case, not Q implies not P. Right, that's what I care for. Start with your statements. Go into each individual part. In this case, not Q and not P. And then I'm going to figure out the very end. So for not Q, it's just going to be the opposite truth value of the Q's. True to false, false to true, true to false, false to true. It's the opposite truth statement of the Q. Not P is the same thing, but with P's. The opposite truth value of the P. Okay? Everyone fine with these first three columns? And now for the last one, it's not Q implies not P. So for there, what I'm doing, or what I'm going to try to do, is I want to see, well, not Q implies not P. That's only not going to work if you have a truth implying a false. That's the only time it will not work. So I'm going to go down this table and kind of see, well, where do I have a true implying a false? That's only right here. And that's why this is the only one false. Right? False implies false. That's okay. True implies false is not okay. I shouldn't put a check mark, put an X. False implies true. That's okay. True implies true is also okay. But a true statement implying a false statement cannot happen. That's the only time you have a conditional being false. We good here? Any questions before I keep going? Go for it. All right, let's keep going. So, conditional statements, you can reverse and negate the antecedent and the consequence, and the statement's truth value will not change. If you're cool, you won't wear clothing with your school name on it. If you wear clothing with your school name on it, you're not cool. I don't know. Either way you go about it, it's the same thing. Basically, just saying you can reverse the order you do it in. It doesn't matter. All right. So now this one's a little more complicated. And again, it just boils down to the same thing. What we want is this big statement right here. That's what I want to prove. All right. So it's all P's and Q's. So I'm going to start my whole thing with P and Q. I want to know all my combinations of P's and Q's. So I start with P's and Q's and all their combinations because the statement is based on P's and Q's. Everyone with me? Or y'all kind of confused? We're good? All right. And then from there, each column afterwards is going to be a small part of the problem that I'm solving for, kind of building up to the big part. We're going to try to break these columns down to each individual part. So in this case, I have P or Q. That's because I have a P or Q here. So here, P or Q, remember that's true whenever at least one of the P or Q's are true. So in this case, the first row, true and true implies true. True or false gives you a truth. False or true gives you a true. False and false gives you a false. Neither is true, so that has to be false. Everyone with me? All right, and then from here, the next small part I have in this big statement is this not P. So that's why that's the next column over. This is the next part that I'm trying to figure out. So not P will just be the opposite truth values of P. So true to false, true to false, false to true, false to true. Okay? So that gives you the small individual parts here. All right. And now what I want to do is I want to figure out, well, what is the truth value of the big statement in this bracket? Because now I have this big statement. Now that I got the two individual parts in it, I got the P or Q and the not P. I got these two statements in here. I can figure out the truth value of the bigger statements. You're kind of building up to get to your bigger statements to understand the truth value of that. All right. So P or Q and not P, the P or Q and the not P, they both need to be true at the same time. And if you look at these two columns, that only happens in that third column. That's where the rest are false, and that one's true. Because they both need to be true, and that only happens once on that third row. And now that you got the whole truth by the whole left side, and I have the Q, what I want now is I want to know, well, when does a true statement imply a false statement? So when this statement right here is true, when does that imply a false statement for Q? Because when that happens, it's going to be false. Kind of a weird way of thinking, but that's what's happening. Everyone with me or not really? Any questions? Which one? This one right here or this one? Do you get how we got this one right here? Yeah, but do you get this one though?
Yeah.
Okay, so let's erase this and we'll figure it out. So this last one, it's an implied statement, right? It's a conditional, it's the arrow. So if it's an arrow, what that means is that the only time this is false is when this whole thing is true and Q is false. So we're looking at this column and we're saying, well, when this goes to Q, when is this true and when is this false? Oh, when is this one false? That's when the statement's false. So here I have false implying a true. That's okay, right? So that's why this one is true. The second column, it's a false implying a false. That's also okay, right? Now I have a truth implying a true. That's still okay, right? So that's why this one's going to be T. And then I have a false implying a false. That's also okay. So it's a true statement. Make sense? Any other questions, guys? All right, let's keep going. All right, biconditional statements. P if and only if Q. So P implies Q and Q implies P. True only when the component statements have the same truth value. What that means, it's only true when when P and Q are both true, or when they're both false. Right? That's the only time they're true. I don't think y'all care. We could break it down to show you why that's true, but I think the better way is just kind of understanding biconditionals are only true when when they both have the same truth value. Okay? Any questions about that? So it's kind of like four things you need to kind of memorize to kind of play with these truth tables. For and statements, the conjunction, the and statements, they both need to be true to be true. The or statements, only one needs to be true for it to be true. A conditional statement, which we just finished, a true cannot imply a false. That's the only time it's false. And finally, biconditionals, it's true when they have the same truth value. Okay? So definition of symbolic logic, I think we already kind of know this, right? Negation means it's a squiggly line, it means not. Conjunction is and, disjunction is or. I think y'all have this down, but y'all want to take a picture? Anyone copying this, or are we good to keep going? We're good? Okay. So we got some more conditionals, if, then, biconditional, if and only if. We've talked about this before. I'm not sure why they're giving it to us again. But any questions here? Or is anyone copying before we keep going? No? All right. Wow. Y'all can read this if you want to, and we can go over it. That is a lot to read. Super $1,000,000 bonus entry. And I'll give a basic example at the very end. That's not this. Has everyone read it who wants to read it? Is anyone still reading it? No one's reading it? Okay. The important part is what P and Q are. It does, or P, Q, and R in this case. It does not matter what the actual statement means or says or whatever. Maybe it's because I'm a math person. I don't care what the things say. I just care what's the truth value, right? P is false. Q is true. R is false. Okay. Not sure why the last part's relevant, but that's what you have. And I want to know P and Q implies R. So that's what I want to know. And that's what we're going to solve out. And again, you don't need to actually make a truth table here. All you need to do is replace it because you know what P is. You know P is false, you know Q is true, and you know R is false. You know what each one is, so you don't actually care what it's saying. All you care about is the truth values. Okay? So this is how you get from here. We want P and Q is R. So because P is false, you can replace it with a false. Q is true, you can replace it with a true. R is false, so you have a false. So false and true is a false statement. False implies false, and it's true. So our truth value analysis indicates that you cannot sue the credit card company for making a false claim. I don't know. Whatever it is, I'm going to give you guys a different example with P, Q, and R that we can actually follow. All right. So let's say P we'll do the same thing, something similar. 10 is less than 15. Q7 is greater than 13. R, I don't know. -3 is greater than -5. All right, this is what we have. So we're going to assign truth values to these. 10 is less than 15. That's true. 7 is greater than 13 is false. -3 is greater than -5. That is true. And let's say, I'm going to give you kind of a complicated one, but it doesn't actually matter. Let's say I have not P implies Q or P if and only if R. Let's do that. Do you want to try this first or you want me to just do it? Try it first? Alright, go ahead and try it. You got ready or you still need a few more minutes? Anyone want a few more minutes? Okay. You ready, guys, or want a few more minutes? Anyone want a couple more minutes, or all right? Let's look over it. So, because we know exactly what P, Q, and R, what their truth values are, you can replace P, Q, and R with their truth values. So P is true, right? So we're going to replace it with true. Q is false, so I can replace it with false. And it's negated. And it's or. P is true if and only if R is true. So you can start replacing the statements with their actual truth values. And then we start kind of simplifying it down from there. Everyone with me? So true implies false. Remember, that's a false statement. That's the only time it doesn't work. True cannot imply a false statement. So what we have now is a negation of F. Right? True implies false is false. So the negation goes down, not false. Or true if and only if true. That's true, right? As long as these are both the same statement, it's okay. That's true. And then from here, not F is true. So if true or true, I only need one of them to be true, but they're both true. So the full statement is true. Does that make sense, guys? So all the stuff boils down to is figure out what are your statements, what's your P, your Q, or maybe even your R. Give them truth values, put them into an equation like this, and just kind of work with it, simplify it all the way down. And I think that is it for me. Like always, I'm here till 10 anyway, or really 9:50. If you want to do your homework here, go for it. If not, you can go home. It's 9 o'clock as it is. But I'm paid to stay here till 10.